So hello, everyone. So I'm Yuichiro Fujimoto, an assistant professor of Nara Institute of Science and Technology in Japan. So today I'm going to talk about projection mapping for enhancing the perceived deliciousness of food. So at first, I have a question for you. So do you like delicious food? So I hope so it looks delicious for you. So as you might know, these are very famous Japanese dish. So, sorry. Okay. So unagi and sushi and yakiniku. Then, so how about these? So do you think these still look tasty? So at least for me, I don't think so. So these are images with the modification is hue or chrome or saturation. So it looks unappetizing, right? So as we can see, the physical appearance of food is very important factors for judging its deliciousness. So here is my research question. Is it possible to control the impression of food if the appearance can be changed, right? So sometimes we may take a picture of the food at a classy restaurant or a home-cooked meal at your home on your smartphone. So after taking a picture, so sometimes image processing are performed to make these images look more appealing and look more delicious. So I would like to do the same things in the real world. So to change the appearance of the food, so spatial augmented reality technology was adopted. So as you know, SAR is a type of augmented reality, and so SAR has big advantage that user does not need to wear special devices. And in this research, we define the subjective impression of the food, judged from the appearance of the food, as DAD, the degree of appearance-based deliciousness. So our objective is to control this DAD using SAR technologies. So one of the applications of this technology is that sales promotion system. So I don't know in other countries, but in Japan, food sample, fake food, are placed in front of the restaurant so that customer can check the appearance of the food before entering the entrance. So I think we can develop such kind of system that, how should I say, so just change of the food look more appealing. So another application is that the systems that help user, like children, overcome their particular food aversion by changing the appearance more appealing. Okay? So there are a lot of research which have evaluated important appearance factors for judging the deliciousness. First one is hue. It is known that blue light decreases appetite, whereas yellow light increases it. So in this image, the image on the middle is under yellow lighting condition. And the second one is chroma or saturation. And it is also known that a beef with low chroma does not look so fresh. And on the other hand, fruits with high chroma represent their maturity and sweetness. And the last one is intensity and highlight. Highlight on the food represents their freshness of food. Okay? And actually, so there are a couple of researchers have been already proposed SAR system for changing the impression of the food. For example, Nishizawa's research reveals that the subjective sweetness of the sponge cake can be modified by changing its chrome. And Huisman reveals that the changing the color will affect the perceived taste of the yogurt. But these research are only focusing on one food or a couple of food. So as far as I know, there is no research for arbitrary food items. Then in this research, I would like to explore a general method which is applicable to various fields. Okay? And so I will get into detail what I did. At first, an online survey was conducted to check what appearance factors are related with judging its deliciousness. So I prepared various food images, which is one of the food appearance factor is modified from the original one. like a chrome or highlight or partial colors. For example, in the partial color apple case, the green part of the apple is changed one by one to red part respectively. So here is the result of the survey. We collected 55 university student responses. So at first, the leftmost bar illustrates the result of the original image. And as we can see, for example, in the apple case, the highlight condition outperformed the original appearance. On the other hand, and partial color modification conditions significantly reduced the impression of the food compared with the original appearance. And beef case, unfortunately, there are a lot of conditions which reduced the impression of the food compared with the original ones. So these results indicate two things. First one is modification should be very carefully performed because too much modification would easily produce negative effect on that. The second one is the same adjustment has different effect depending on the food. Okay, so based on these findings, I developed the projector camera systems. I will not get into detail here. So there are 4 pre-processing steps. At first, geometric calibration and color calibration are performed to compensate the difference between projector and the camera. And next, so food region segmentation is performed. And finally, and so different intensity light are projected onto the food surface to extract highlighted region, which are used for the later processing. And there are 4 appearance factors to be modified: intensity, chrome, highlight, partial colors. In this first prototype, one of them is modified at once, and the amount of the modification has been empirically determined in advance and by manually. And here is the result. So at first, the video looks very dark, but it is just for recording problem. So of course, actual system is applicable to a normal lighting condition, and the experiment is performed under normal lighting conditions. And so unfortunately, the appearance in the video image is totally different from the appearance in the real world. So it is very difficult to express, let you know what the actual appearance is. But I hope you can see the appearance of the food is changed from the original one. Okay. Okay, so to check the effect of the first prototype, a small experiment was conducted. So I prepared 3 food items: apple, assorted sushi, and steak. And so I prepared 15 different projection conditions, like these images. And so the participant asked to score the impression of the food by randomly looking at these not images, these real food under the projections. And so here is the result. So at first, so the horizontal axis illustrates, vertical axis illustrates DAD. So of course, higher is better. And the dotted line indicate the result of the original appearance. And as we can see, in the upper case, weak chroma condition outperformed than the original condition, and as well as partial color modifications. And in the steak case, we can see there are a lot of conditions which outperformed than the original conditions. Okay, so here is the summary of the experiment 1. So we found more than one lighting condition with higher DAD than the original one for each food items. I think this is very promising because this result indicates there is room to improve the impression of many food if we can correctly choose the best projection parameters. So obviously, we have serious problem on this first prototype. So manual parameter tuning is needed for each food. This is not practical. So our next step is to make this process automatic. To do that, we need a model between the appearance changes and the DAD. But as I mentioned, so same projection parameter obviously have a different effect on the each food items. On the other hand, it would be impossible to make each model for each different food items all over the world. It's impossible. So we defined 7 food categories: fruits, vegetable, meat dish, fish, and noodle, and rice, and bread, and sweets, as a reference of EPFL food image dataset, and to make a model for each 7 food categories. So to collect the data for modeling, so I used Amazon Mechanical Turk to perform an online survey. But here, I also have a serious problem. Obviously, the impression from the image is different from the impression from the real food items. So I can easily assume it would be very difficult for the responder to correctly perform absolute scoring for the real food items. So, here, so I adapted a pair comparison instead of the absolute scoring. So this is because I think a pair comparison is much easier, even if the user have some difficulty of scoring the absolute score. And as you might know, it is very easy to calculate absolute score from the result of a pair comparison with a specific method. And so I used these calculated score for the modeling. And so here is the result of the example. And so first line indicates the meat dish, and the vertical line shows the DAD, and the horizontal line shows each appearance factors. For example, look at this graph. And as we can see, the intensity value peaks around 100 in this case, and from decreases it. And on the other hand, chroma is linearly increasing like this. And the second line indicates the rice dish. So as we can see, each graph shape is totally different from each other's. And based on the constructed data, constructed model, so I developed a second prototype. At first, image is captured, and each image is classified into 7 food categories by the image recognition, and the corresponding DAD model was adapted. So then the image segmentation is performed, and for the segmented areas, so appearance features are calculated. So next, this is important, and so each appearance factor is modified a little bit so that the DAD value increases than the current values, okay? And with updated parameter, projection is performed. Then the camera captures the image again under the projection. Then, so the appearance factors are computed again. So these procedures are repeated. DAD is converged with a high level. So to find a best projection parameters in an exploratory manner. So after these iterations, we finally get the final image projection result. So this is an example of the projection. So this is a fried food case. So fried food, like a fried chicken, looks fleshy by changing the chroma values like this. This is original one. This is automatically calculated appearance. So finally, so to check the effect of this second prototype, so small experiment was conducted again. We prepared 14 food items and 3 different lighting conditions. Condition A is original one with normal LED lighting. Condition B is uniform lighting by a projector as well as normal LED lighting. And condition C is optimized lighting by a projector as well as LED lighting. And at first, so original appearance looks very dark, but it is just for the camera setting problems. So actual appearance is much more natural. And so in this case, we regarded original appearance result as a baseline. So the score is always 50, and participants were asked to compare condition B and condition C with condition A. And please look at green boxes for condition B and pink boxes for condition C. So as we can see, condition C outperformed than the condition B. Apple case and cake and toast and this Japanese noodle dish, yakisoba. And but on the other hand, so if we look at sushi and donuts, so condition C did not show such kind of significant effect. Okay. So finally, I would like to share the remaining challenge of this study. We checked the proposal method works well, relatively works well. So for the food with uniform appearance like apple. On the other hand, so we can easily assume current simple method using 7 food category did not work well so much for such kind of complex object which containing various different appearances like assorted sushi. And how to deal with such a complex food would be one of the future research. And so the second challenge is more related with human perception. As I mentioned, the impression from the image is totally different from the impression from the real one. So how to model this relationship will be very important, not only for this research, but also for other research as well, which would like to model human perception in the spatial augmented reality or optical see-through HMD type systems. Okay, here is a summary. So my research question was, is it possible to control the impression of food if the appearance can be changed? So my answer is yes, but there are much room for improving model of the human perception. Okay, that's all. Thank you for your attention.